the last little bit that I am going to add in here is the idea of a relative minimum and a relative maximum. So I'm really going to look at this graph that we just used, the x squared times x minus 4 times x plus 2. We have our sketch. Okay. Now, each one of our turning points is either a relative minimum or a relative maximum. Right here, this guy is a relative minimum because in the neighborhood, it is a low point. This turning point here is a relative maximum because in the neighborhood, it's our highest point. Now, the key here being a relative maximum is really important because it's a relative maximum here. It's not a maximum for the whole function because these arrows, keep in mind, tell us that our function is going to keep, our y values are going to keep increasing. So it's not a maximum for the whole function. It's just a maximum for this little neighborhood that we're in. And then right over here, whatever this turning point is would also be a relative minimum. So we can find these relative maximums or relative minimums on our graphing calculators. And that's what I'm going to show you here really quickly. And our process is actually the exact same for how we found the vertex of a parabola. So our process, we go to our calculator, we type in under y equals, okay, I'm going to get back to my main screen here, y equals, we type in our function, and you could use the factored out form or the original, x plus 2, and then we'll take a look at our graph. Try to focus this a little bit better here. There we go. Okay, so I can see my relative minimum here, my relative maximum. I don't know where this other relative minimum is, so I need to adjust my window a little bit. But I don't need to see anything up here. So I'm going to change my window, my y min. I'm going to try changing this to -20 and my y max to 5 right now. Okay. Because I know I need to see further below. I know I don't need to see any higher up. And I still need to see a little bit more. So back to my window. Try changing this to -3 and then y max 5 again. There we go. That gives us everything we need to see. So second calc, if I'm trying to find my minimum here, I want second calc minimum. And if I'm trying to find this minimum, okay, move your cursor over. It says left bound. We just need to be on the left side of that minimum. Hit enter. Right bound, we need to go to the right side of our minimum. Hit enter. And then guess, we hit enter one more time. So we have a relative minimum at negative, if I round this, negative 1.39, negative 6.35. Okay, and I'll add that to my little graph here. Okay, my relative maximum, I guess I can kind of cheat because I know that this is my turning point at my x-intercept. But to go through our process again, second calc, this would be a maximum. So second calc, maximum. This is what I'm trying to find. So left bound, I just need to be on the left side. Enter, right bound on the right. And guess is enter one more time. Keep in mind we sometimes have weird rounding things, okay? So this E -6, e negative 11. This is really 0, 0. And then my other relative minimum here, this point, we go to second calc. Minimum, left bound, I just need to be on the left somewhere. Right bound, we go to the right. Hit enter one more time. We're at 2.89, negative 45.33. And as you can see, our loose sketch that we made without knowing where our relative minimum and maximum were, our rough sketch was pretty far off because we did not show that this was really quite a bit farther below the x-axis than our other relative minimum. Okay. But that's how we find them on our calculator.